Assalamualaikum everyone. In this episode, we tackle thermal linear expansion of two rods with different kinds of materials joined end to end to form what we call a composite rod. Join me as I help you analyze the factors that affect the thermal expansion of a rod. Just hang on, watch and learn. The question is, a metal rod that is 30.0 centimeters long expands by 0.0650 centimeters when its temperature is raised from 0 degrees Celsius to 100.0 degrees Celsius. A rod of a different metal and of the same length expands by 0.0350 centimeters for the same rise in temperature. The third rod, also 30.0 centimeters long, is made up of pieces of each of the above metals placed end to end and expands 0.0580 centimeters between 0.0 degrees Celsius and 100.0 degrees Celsius. Find the length of each portion of the composite rod. Since the composite rod consists of two rods of different materials, let's describe each of them first before they were joined. The first rod had an initial length denoted by L sub naught 1 equal to 30.0 centimeters. When heated and had a temperature change of 100.0 Celsius degree, rod 1 changed its length delta L sub 1 by 0.0650 centimeters. Rod 2, on the other hand, which also had an initial length L sub naught 2 equal to 30.0 centimeters and was also heated for the same delta T of 100.0 Celsius degree, had a length elongation delta L sub 2 equal to 0.0350 centimeters. When these two rods were joined end to end, a composite rod was formed, having an initial length, all right, L sub naught 3 equal to 30.0 centimeters. When heated by the same change in temperature delta T, all right, uh, the change in temperature is 100.0 Celsius degree. This composite rod had elongation delta L sub 2 or delta L sub 3 equal to 0.0580 centimeters. All right. We also emphasize that all the three rods were heated such as to have the same temperature delta T, which is 100.0 Celsius degree. All right. This means that uh, the initial temperature, all right, could be 0 degrees Celsius and the final temperature is 100 degrees Celsius. All right. But that could also mean that the initial temperature can be at room temperature, such as 25 degrees Celsius, then heated until the final temperature becomes 125 degrees Celsius, all right, it doesn't matter what the initial temperature of each of the rod is as long as the change in temperature delta T is 100.0 Celsius degree, all right? So a target variable or variables, all right, we have to find the initial length of the portion of the composite rod that is made from rod 1. We label that as L sub naught 3, 1. And the rod 2 portion of the composite rod, its initial length is labeled here as L sub naught 3, 2. All right? As shown in this illustration, all right, the composite rod is actually made up of the two rods, rod 1 and rod 2, connected end to end. All right? So the resulting composite rod has the same initial length labeled here as L sub naught 3. All right? But as you will notice, the portion of rod 1 is longer than the portion for rod 2. This is because it was stated earlier that the change in length for rod 1 happens to be greater than that of rod 2. That's why we are able to predict, all right, that the value for L sub naught 3, 1, all right, will be longer than that of the initial length of rod 2 or L sub naught 3, 2. The basis for our succeeding calculations is the formula delta L equals L naught times alpha times delta T. Okay, this formula tells us that the change in length delta L, also called the elongation of the rod, depends on factors such as delta T, all right, or the change in temperature. This means that the elongation delta L is directly proportional to delta T as long as the change in temperature doesn't exceed 100 degrees. All right? So the elongation delta L also depends on the initial length of the rod, or L sub naught. And delta L is also dependent on alpha. All right? Alpha here is known as the coefficient of thermal linear expansion for a given material. Okay? So, we first calculate this coefficient of thermal linear expansion, alpha, for rod 1 using the formula alpha 1 equals delta L1, all right, that is the change in length or elongation for rod 1, divided by the product of the initial length of rod number 1, labeled as L naught 1, and the change in temperature delta T. So when we substitute the given values, alpha 1 is just equal to 0.0650 centimeters, that is delta L1, to be divided by the product of L naught 1, which is 30.0 centimeters, and the change in temperature delta T, 100.0 Celsius degree. All right? So doing our math, we get the value for alpha 1 equal to 1.17 raised to the negative 5 per Celsius degree. Take note, we are applying the rules of significant figures. Right? Now, similarly, for the second rod, rod 2, right? Alpha number 2, all right, is also equal to delta L number 2, or the elongation of rod 2 divided by the product of its initial length, L naught 2, okay, multiplied by its change in temperature. So, substituting the given values, we get alpha 2 equal to 0.0650 centimeters divided by the product of 30.0 centimeters and 100.0 Celsius degree. Doing our math again, we get the value of alpha 2 equal to 1.17 raised to the negative 5 per Celsius degree. All right. So these are the values for the thermal coefficient of thermal linear expansion for rod 1 alpha 1 equals 2.17 to the negative 5 per Celsius degree, and for rod 2 alpha 2 equals 1.17 raised to the negative 5 per Celsius degree, both in three significant figures. All right, so moving on now to the computation of our target variables, we focus on the composite rod whose initial length, L naught 3, all right, is also given as 30.0 centimeters. And we will let L naught 31 as the length of the rod 1 portion, all right? And the rod 2 portion, of course, is equal to the difference, all right, between 30.0 centimeters and L naught 31. In other words, if one portion of the composite rod, all right, the rod 1 portion is represented as L naught 31, therefore, the rod 2 portion is represented as 30.0 centimeters minus L naught 31. All right? Now, since the change in length of the composite rod, or delta L3, is given in the problem, all right, we can just equate this delta L3 to quantity L naught 31 multiplied by alpha 1 plus L naught 32 multiplied by alpha 2, all right? So their sum will be multiplied by delta T, all right? And substituting the given values, our target variable, of course, is L naught 31 as well as L naught 32, all right? So 0.0580 centimeters is the given value for delta L3. That is equal to the product of L naught 31, all right, and alpha 1, which we have earlier calculated as 2.17 raised to the negative 5 per Celsius degree. So that will be added to the product of 30.0 centimeters minus L naught 31, all right. So this quantity pertains to the inertial length of the rod 2 portion of the composite rod, which will be multiplied to its value of the coefficient of thermal linear expansion, or alpha 2, all right, which we also earlier calculated as 1.17 raised to the negative 5 per Celsius degree. And then all of this will be multiplied by delta T, 100.0 Celsius degree. So finally, doing our math, we will arrive at the value of L naught 31, or this is the length, initial length of the rod 1 portion of the composite rod, equal to 23.0 centimeters in 3 significant figures. And of course, the rod 2 portion of the composite rod, which is 30.0 minus 23.0 centimeters, that will give us, of course, the value for the rod 2 portion, or L naught 32, equal to 7.0 centimeters. So, that will be all for now. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.